Okay, pre-calculus. Today we're going to start the third topic in this chapter, and it is the question of what happens when a region is rotated about an axis. So what I mean is we can see our region in here. We're going to rotate this about the x-axis. So I'd like you to think about, in your notes, drawing this axis in. Well, what shape would that be? If we can try to visualize this a little bit, we always want to make sure our cuts are always perpendicular to that axis of rotation. And we need to imagine this like spinning around. So I've got a piece of software I want you to see. I've got a question much like the one we did here. We're going to be rotating this about the x-axis. And I want to see what that looks like. So I've got my volume here, or my area rather. I'm going to rotate it about the x-axis. And as those pieces rotate about the x-axis, it's making a three-dimensional shape. Now that three-dimensional shape is a cone, but we do not have to worry about if it makes whatever three-dimensional shape. We just have to look at this and notice that it is made up of a bunch of disks. And to help you see that a little bit, I'm going to, so we see these rectangles now. I'm going to rotate these again about our axis of rotation here. And maybe now we can kind of see it a little bit better. Right. So what we have to do is find the volume of these disks. And the disks are just pi r squared, right? So if I go back to the notes here, again, this is what we're kind of doing here. It's really pretty neat. Let's go back to our notes. Now notice I've got it up here at the top. All right, pi radius squared. Now the radius, if I draw this a little bit nicer, and here's our axis of rotation. And this is our cut. The radius is the distance from the axis of rotation to the farthest point on the cut. So this distance here is r. So if we were to find the volume of this, again, our note said it's, pi r squared. That's the area of a circle. So we would say pi. Now r, that would be the top. How long is this? How long is that cut? Well, top minus bottom, right? Well, the top curve is x squared, and the bottom curve is the x-axis, which is 0. Right, so there's pi r squared. And we're going to integrate that between 0 and 1. Whoops. Even when I'm making a video, I've got to plug in my stupid computer. There we go. Okay, so that's the setup for that. It's really not that bad a deal on these. Let's look at another one. This time we want to rotate it about the line x equals 1. Well, again, I'm going to draw my axis of rotation in here. And the key to remember on these is that our cut always will be perpendicular to the axis of rotation. Now this tells me this is a dy. So I need to solve this equation for x. So x would equal the square root of y. And now, again, remember the area of that circle It's pi r squared. And radius is the distance, it's from the axis of rotation all the way out, right? How long is this? Well, again, it is right minus left, just like we do with the area between the two curves. Well, the right side is 1. I know it says x equals, but it's okay, it's 1. So 1 minus the left side, which is the square root of y. So that's our radius. We're going to square that and do a dy on it. Pi. Now, the rectangle, it's going to be sliding from all the way down here at 0 to all the way up here at, this is at the point 1 comma 1. So all the way to the point of 1. This is our setup. This is volume by rotation. This is our very first day of it. Now, on homework, I just want you to do a couple problems, and then we're going to keep working on them the next day. What I want you to be aware of is that sometimes when things rotate, like if we think about this one rotating about the x-axis, right, we can imagine that there's going to be a bit of a hole left in here. Okay, so what I want you to do is the ones that we're doing today, there's going to be no holes in them. I want to save the questions with holes in them for us to talk about Friday. Okay? All right. Well, good work, everyone. Please get the questions done. You'll see it on Google Classroom.